In this video, we pay attention to the Fibonacci sequence, and what we are looking for is to find a recurrence equation, and via the recurrence equation to find a closed formula. The first term of the Fibonacci sequence is 0, then 1, then to get to the next term, you add the two previous terms in the Fibonacci sequence. Then you take 1 and 1, you add them together, you get 2. 2 plus 1 equals 3. 3 plus 2 equals 5. 5 plus 3 equals 8. 8 plus 5 equals 13. In order to go to the next term, you add the two previous terms. So the first term of the Fibonacci is 0. Adding 1 gives you 1. 1 plus 1, 2. 2 plus 3, 5. 3 plus 5, 8. 13, etc. What we are looking for now is to find a recurrence equation, and from the recurrence equation to find an explicit formula that describes the sequence. So here we notice that we have fn, fn plus 1, fn plus 2. So in order to get the next term, we add the two previous. This means that fn plus 2 equals fn plus fn plus 1. So fn plus 2 equals fn plus fn plus 1. I used an ansatz here. Fn equals w to the power of n, w to n plus 2 equals w to the power of n plus w to the power of n plus 1. This can be written as w to the power of n times w squared. We use the laws of indices. We take the common factor to be w to the power of n at the right hand side. We divide by w to the power of n, provided that is not equal to 0, so we have w squared equals w plus 1. W squared minus w minus 1 is equal to 0. It's a quadratic equation. We find the discriminant, which is 5. W1 is minus 1, so it's 1 plus square root of 5 divided by 2. And the other root is 1 minus square root of 5 divided by 2. So my Fn, my sequence, is a constant a times w1 to the power of n plus a constant b times w2 to the power of n. This a is 1 plus square root of 5 divided by 2 to the power of n plus b 1 minus square root of 5 divided by 2 to the power of n. We know that the first term of the Fibonacci is equal to 0. So for n is 0, a plus b is equal to 0. And from here we can eliminate the constant b, which is minus a. So Fn can be written alternatively in this way: a times 1 plus square root of 5 divided by 2 to the power of n, minus a times 1 minus square root of 5 divided by 2 to the power of n. I can take common factor the coefficient a, and I have inside the brackets 1 plus square root of 5 divided by 2 to the power of n minus 1 minus square root of 5 divided by 2 to the power of n. For n equals 1, the second term of the sequence is 1. We have a times 1 plus square root of 5 divided by 2 minus 1 divided by 2 plus square root of 5 divided by 2 equals 1. So from here we have a, the 1 divided by 2 minus 1 divided by 2, these terms are eliminated, and we have 2 times square root of 5 divided by 2, which is square root of 5, equals 1. A equals 1 divided by square root of 5. A is square root of 5 divided by 5. As a consequence, the explicit form for Fn is the following: Fn equals square root of 5 divided by 5, 1 plus square root of 5 divided by 2 to the power of n, minus 1 minus square root of 5 divided by 2 to the power of n. By using this formula, I can obtain the other terms of the Fibonacci sequence. For n equals 23, I can obtain the term of the Fibonacci sequence for n equals 24, 25, 26. This is a helpful formula because I don't have to, in order to go to a big term, I don't have to add all the previous terms and so and so and so to find it painfully. I can use a formula, specify what is n. Of course, n should be an integer, a strictly positive integer from 0 to 0, 1, 2, 3, etc. And this will help me gather the other terms of the sequence less painfully without having to add terms each time and make things complicated.